Hello everyone, welcome back to Maths Problem Solving. Today we're going to be doing a algebra question from an Olympiad. So yeah, let's get into it. So the question's asking us to solve these pairs of simultaneous equations. So let's label this equation 1 and equation 2. So one thing we should know about simultaneous equations is that we need to always set both the simultaneous equations in the terms of each other. So we need a way in which this positive 4 can equal, effectively, this 2.5. So if it isn't clear, I'll just write this. So 5 times equation 1 minus 8 times equation 2. Now, the reason why we're doing this is because we want 5 times 4 is 20, and 8 times 5 divided by 2 is also 20. So if we just write this as this, a plus b, a squared minus b squared equals 20. 5 times all of this equals 20. And 8 times a minus b, a squared plus b squared, this also equals 20. So the first equation is the 5 times 1, and the second one is the 8 times 2. So basically, now what we have is we have two equations which are equal to each other. So 5, a plus b, a squared minus b squared equals 8 times a minus b, a squared plus b squared. And okay, so this is basically our next step, and now we can start simplifying this a bit more. So the a squared minus b squared term, we can rewrite that as a plus b, a minus b. Remember, it's the difference of two squares, because a squared minus b squared is the same as a plus b, a minus b. And there's also this. Sorry, this is not an equals to. This is an equals to sign, not a plus sign, that's what I meant. A minus b, a squared plus b squared. Okay, so now there are many a and b terms, but we can start simplifying. So this a minus b and this a minus b, we can remove from both sides. So let's divide everything by the term a minus b. So we can write this as 5a plus b all squared equals 8a squared plus b squared. And now let's just write this a bit more simply. So a squared plus b squared is not the same as a plus b all squared. So what we'll need to do now is expand this out. So this 5 times a plus b all squared equals this, effectively. Because remember, a plus b all squared is a squared plus 2ab plus b squared. So we can write this as that. And the right-hand term as this. So now let's collect all the like terms on the left-hand side. So we get minus 3a squared from 5a squared minus 8a squared plus 10ab minus 3b squared. And all of this equals 0. So now we have like a somewhat regular quadratic to solve. So let's just multiply everything by minus 1. It's just much easier to work with when the the squared term is a positive square, since we can't really work with it if it's a negative square. So this is what we get left with. And now we need a way to factorize this effectively. We could use the quadratic formula to work out what b is in terms of a, but it gets very messy very quickly, and remember, this is an Olympiad paper, so there's lots of time pressure, and we need to just work through this quite quickly. So now the minus 10ab term, we need to split this so it can be factorized by these other two. Now it's not going to get factorized by minus 5ab and minus 5ab, but it will get factorized by minus ab minus 9ab. So if we write that as this, minus ab minus 9ab plus 3b squared, and all of this equals 0. So now let's just factorize this. So we can factorize a out of the first couple of terms. So we get a 3a minus b. And now hopefully, if everything works out, we're going to get the same thing with the minus 9ab plus 3b squared. So let's also factorize 3b out of all of this. And now let's just be very careful with the negative signs. So positive 3a, because positive 3a times negative 3b equals minus 9ab, minus b equals 0. And now we have 3a minus b on both sides. So we can write this as a minus 3b, 3a minus b. All of this equals 0. And now we have a link between a and b, which is much cleaner than what we would have derived if we had used the quadratic formula. So now a minus 3b can equal 0, or 3a minus b can equal to 0. And now let's just solve the left-hand one first. So a equals 3b, or 3a equals b. So now we have two separate possibilities. So a can either equal 3b or b can equal 3a. So now if we just substitute this stuff back into our original equations, we should be able to get somewhere. So now these original ones, let's just move them down here. So a plus b times a squared minus b squared equals 4. And now we have a in terms of b and b in terms of a, so this should be quite simple in theory. So let's just start by working with the a equals 3b. So then we can write this as 3b plus b times 3b all squared minus b squared equals 4. So now let's just write this a bit more simply. So 4b times 3b all squared is 9b squared. So we can write this as times 9b squared minus b squared, which is 8b squared. And all of this equals 4. Now let's divide through by 4. And we get b. Okay, hang on. Before we divide through by 4, let's write this as 32b cubed equals 4. And therefore 8b cubed equals 1. And therefore b cubed equals 1 divided by 8. Divided by 8. And now if b cubed equals 1 divided by 8, therefore b must equal 1 divided by 8 cube root, which is just a half. So now we have a term. Now we have one possible value for b, which is a half. And now let's just go back over here to the very top and write our solution. So if b equals a half, we know that in this term we assume that b equals 3a. 3a equals b. Let me just double check that. A equals 3b. So then we know that a would equal 1.5 in this possible solution. So now let's work through the second solution set. So in the second solution set, we have 3a equals b. So now the same equation, a plus b, a squared minus b squared equals 4. And we have that 3a equals b. So now we can replace all the b terms by 3a, and we get the exact same as what we would get over here. So hopefully you can just see this, that we don't really need to go through the whole process which we went to on the left. If a equals a third b, or b equals 3a, so then we're basically going to get the same thing as the right. Therefore, in this case, a equals a half, and for this value of a, b would equal 1.5. So now let's go back over here. Our other set of values are this. b equals 1.5, and a equals a half. Okay, so yeah, we're basically finished with this. So it's very key in our final step of working just to write these terms as pairs, because you sometimes lose marks. Even if you wouldn't lose your marks in a GCSE exam, you might lose your marks in an Olympiad paper for not pairing these values up. So yeah, we're basically finished with the question. So now the key learnings which we have from this singular question, is that it's a simultaneous equation, but the way we achieved this was how we achieved any simultaneous equation, which was just writing both of them as equivalent terms and just working through it like that. And yeah, I hope you learned something. I hope you found this useful. If you did, be sure to subscribe and like, that would be very much appreciated. And watch another one of the videos if you would like to do so. Thank you for listening, and I hope to see you later in a future video. Bye.